Hello and welcome to today's FastCast webinar, a 30-minute approach to keeping facility managers in the know. Our session, How to Predict, Plan, and Prevent with Lifecycle Costing for Facilities, is brought to you by Facilities.net and the Gordian Group. My name is Nicole Benke and I will be today's moderator. The first part of the presentation will outline how to effectively use cost data, leading into a live lifecycle costing demo using this data in a sample project. As a reminder, there will be no Q&A in this session, but we still encourage you to submit questions for follow-up offline, as we appreciate any questions and feedback you have to offer. Today's speaker is Dave Lewick. He is the Principal Consulting Engineer at RS Means from the Gordian Group. He has over 38 years experience in construction management, as well as holding a Master of Economics degree. Let's welcome Dave.
Thanks, Nicole. Hey, welcome. My name is Dave Lewick. Today's topic is how to predict, plan, and prevent with life cycle costing for facilities. I have the opportunity to go on the road quite a bit for RS Means, and a number of the questions that I receive in the marketplace include: how do you handle small repair and remodeling projects quickly? How do I anticipate the total ownership cost of my facility? What's the true life cycle cost of my facility? How do I manage aging infrastructure with the continuing advancements in technology? And I think what they're trying to drive at there is they're keeping the old buildings, and we're dealing with new advancements of technology being interjected into these older facilities. And that creates quite a challenge, both to do the work and to figure out the cost of doing that work. Another question I get is, how do I adjust my anticipated budgets for changes in product pricing? Now we're getting to another level. We're trying to look forward a little bit and use some analytics to help us predict some pricing in the future. Another question might be, how does deferring maintenance impact my facility's life cycle cost? And that's a real important question, as sometimes the economy or a business operating isn't going as well as one would think, and things do get deferred and preventive maintenance gets delayed, and people would like to know the impact on their life cycle cost when things like that happen. Primary focus of what we're doing today is what resources are available to help me justify my current and future maintenance and repair costs to finance and senior management. We're always selling. We're selling our number. When we have a database such as that from RS Means, which has stood the test of time, subject to audit, has a large group of professionals compiling the data on a yearly basis, we're in a better position to sell our budget or our proposed cost for preventive maintenance or repair in perhaps capital improvements. Some motivational factors for doing preventive maintenance. You can increase leasing income, perhaps to get involved in environmentally friendly operational through LEED. Prospective tenants and their questions, talking about reliability and HVAC systems and air quality and sustainability. By doing preventive maintenance, certainly we put ourselves in a better position to attract tenants. If capital expense dollars are saved, doesn't that leave cash for development? Absolutely. So if we can justify, we can show some expenditures actually save more money that can be used for other critical corporate activities, that's a great thing. Is the construction team shifting problems to operations? On the other hand, do we create our own crisis? Is fixing a problem more motivating than preventing one? Sometimes that fix gives us the elixir or the rush that we've really done something here. And preventing is, at least for perhaps the maintenance staff, not as sexy, for lack of a better term. Popular reasons why we perhaps might not do preventive maintenance. If it's not broke, just don't fix it. Some people are in a position where they're just barely keeping up with repairs, so there's no time for any work that isn't absolutely essential. Nobody's complaining, so we must be doing something right. Probably not the right tack to take. There are different metrics to look at when we're trying to evaluate how we're doing. There's no money in the budget. We're stretched so thin, just cutting staff. I go to so many different facilities where they are eliminating maintenance staff through attrition. When someone retires with all their institutional knowledge, they're not replacing them. They're maybe outsourcing, or maybe they're doing less. So that happens. It's under warranty. Well, warranty usually requires certain amounts of preventive maintenance to be done, or you void the warranty. All maintenance is contracted out. Again, not the right way to look at things. Even though it's contracted out, we need to have an assurance, and even if the onus is on us as facility managers, we need to make sure that our maintenance contractors are performing the proper amounts of preventive maintenance. So looking at ongoing facility investments after initial construction. Many in our profession are so concerned, and rightfully so, with the initial cost of construction. How am I going to get this $10 million? How are we going to make this happen? And somehow you do. But then you start the building, turn the keys over to the owner, and now we've got to take care of it for many, many years. So we have a variety of investments that we are usually responsible for. Preventive maintenance, as frequently as a weekly basis, monthly, just doing things once a year. Repair maintenance, and a piece of that is cyclical component replacement, where things we recognized will fall or fail or break, and we should try to cut that off before it actually happens. And then we have capital renewal, when we actually have to get rid of a building, put a new building in instead, all of which could be deferred, but all of which are real in our world, and which means can help you with our various cost databases. How can cost data help all of us? Project building life cycle costs to allow for accurate budgeting and deferred maintenance avoidance. Help us quantify existing deferred maintenance liabilities. Condition assessments are popular. Some organizations do them every 3 years, every 5 years, every 10 years. But you need to know where you stand in terms of the next several years. Means data can help with that. Provide a basis for effectively modeling current replacement value. Cost data can also help us provide a pricing mechanism for efficient execution of deferred maintenance programs. It can also help determine when deferred maintenance is identified and prioritized. Perhaps there are different delivery methods, including job order contracting, that can help us expedite procurement of repairs. Means offers different cost data types for different purposes. For asset management, we have a database called Facilities Maintenance Repair. This falls in our world of looking at life cycle costs, which is one of our primary emphasis today. This database includes repair maintenance, capital renewal. It also has a large section on preventive maintenance and also information on general maintenance. And what do we mean by general maintenance? General maintenance is basically window washing, floor washing, just taking care of the everyday maintenance needs in your facility. So again, for facilities maintenance repair, in that database, maintenance and repair, preventive maintenance, and general maintenance costs. Here's a sample of a piece of this database. In this case, we're in the repair section, and this gives us pricing for, in this case, in our example, an evaporative condenser. And it gives us cost data for repairing that evaporative condenser. And you'll note that the table shows a frequency 10 years. Once every 10 years, you should have to repair something like this, a 20-ton evaporative condenser. And it tells you all the steps you need to do to make the repair, the labor hours associated with each step, and the total cost, whether you're doing it with an in-house mechanic or you contract it out. It also gives the cost to replace that same evaporative condenser. In that case, it's telling us the frequency is once every 15 years. That's the proposed life cycle through many, many years of observation and the manufacturer's recommendations and indications of how long that something like this should last. Again, it'll give us the elements, remove and put something new in, the hours that it takes, the dollars that it costs, and you compare whether you do it with your in-house or with an outside contractor. Capital planning, long-term planning, again, most frequently 3, 5, or 10-year plans. Typical could be arbitrary age replacement, can be planned by almost anyone, or the alternative is a more nuanced and a skilled evaluation to replace or upgrade based on condition, which varies and is not strictly time-based. There we need the intelligence of people like ourselves that are in this industry, that have seen things, that know how long things last, that can evaluate things within the context of what's happening in our facility. Capital renewal. Similar to just what we just saw, this is the removal and replacement of something. In this case, we're looking at a water heater. An old one needs to be removed and a new one put in place. Again, it gives us great cost information, and it tells us how long this takes in labor hours. One of the great things about the data that you see from Means is that the labor hours helps us with our productivity. Not only do we help you with, can you get assistance with how much things are going to cost, but it also gives you great assistance in how long it's going to take. So it helps you with the time aspect as well as with the money aspect of things. Here's a slide showing us a typical preventive maintenance, both plan and cost. Here we have for a solar water heater, we're listing 19 different tasks that a maintenance person should do, and we list the frequency of the tasks. In this case, everything is either done just once a year or both semi-annually and annually, twice a year. It tells you the labor hours, down to the thousandth of an hour for each task. And it gives you the cost at the very bottom of the slide, where it gives you the cost annually. You're doing things just once a year, or annualized, you're doing everything that's been checked on this checklist. This is a great piece of information here. Some organizations don't have a formal preventive maintenance plan. This is a great starting point if you don't have one, or a great checkpoint if you do have one. Life cycle costing. We're going to look at two different definitions here for life cycle costing. The ASTM definition reads an economic method of evaluating a project in which all costs arising from owning, operating, and maintaining and disposing of the project are considered. These costs are added over the life of the project. All costs are converted to present values. We're trying to bring every cost to a particular moment in time using today dollars rather than dollars down the road. Now, RS means we've taken a little bit of liberty with this definition, and our life cycle cost definition is a little more focused. An economic method of evaluating a project's preventive maintenance, repair maintenance, and capital renewal costs. So we're really taking a shorter view of when the building is actually up and how we're going to project our cost over the lifetime of a building. So these costs are added over the life of a project or a specific time frame. We have the capability of setting a 3, 5, or 10, or even up to 25 or 30-year time frame. So this is a good opportunity to move into our demonstration. At this point, we want to introduce you to the RS Means Online. We want to really focus on the square foot estimator and then life cycle costing. This is going to allow us to choose from one of over 75 different model types that we have in order to get pricing for a brand new building. So let's see how this works. The estimate header information, we have commercial as opposed to residential data that we're looking at. We're using standard union wages. We have other options to go to an open shop, but we're going to stick with standard union wages. We have a release date of the 2016 cost data, which we want. Right now, we're set on national average prices. However, we want to make a change. I'm working from the Boston area. We'll make the change from the national average to Massachusetts and Boston, and we'll save and continue. So now by that simple application, we have changed all the data to the correct material cost and the correct labor cost for the Boston area. Of the other fields that we need to have the option of filling in information, the key one is to name our estimate. So I'm just going to name our estimate RS Means, and I'll leave the other fields open. So now we've named the estimate, we've localized the estimate. Now we want to select the building type. Again, I mentioned we have 75 different models to choose from. First one, they're listed alphabetically, is an apartment building, but we're going to scroll down and we're going to find an office building. We'll choose a 2 to 4 story office building. And to further identify our project and price it correctly, we'll choose a wall and framing type. We're going to go to glass and metal curtain wall and a steel frame. Then we move to the next step, which would be building parameters. We have populated our fields here with information from a typical 2 to 4 story office building. You see that the area, we have a range that means has set at anywhere from 4,250 square feet to 92,000 square feet, pre-populated with a 20,000 square foot number. We're going to change that number to 30,000 square feet. We're looking for a little bit bigger of a project. By doing that, that has made some changes already in the perimeter. The program takes care of that change. We'll keep the stories, number of stories at 3. Story height currently is listed as 12 feet. We're going to change that to 11 feet. So there's the capability of doing some fine-tuning to the way that your project is actually going to look, which will help in determining better and more accurate costs. Now we have some other fields, including contractor's fee. Contractor's fee in our world is defined as not only the overhead and profit for the contractor, but the general conditions. Means rule of thumb of general conditions is 5 to 15%, with 10% being the most normal way to look at things. 25 is not a bad starting point. We're going to say it's more an aggressive market here, and we're going to make a change and make that 22% for our contractor fees. Since we've taken a swipe at the contractors and knocked them down a little bit, we'll do the same with the architects. Hope to get a better buy rather than 7%. We'll plug in a 6% fee. We also have the ability to, if we so choose, add what we call user fees. And basically, this is just the opportunity. So if we have a complex project, maybe we have some difficult site logistics, maybe there are some other geotechnical differences that we may have to deal with, this is a place to plug in a higher risk. So I'm just going to add another percent in our user fee. We also have the capability of including a basement or not. We're going to choose not to include a basement. The next step is building additives. This is optional. Means has captured most of the major elements in the building, and I'd suggest upwards of 98, 99%. There are a few other things here that give you some options. So now we have an office building that we've done a degree of customization. We want to save our estimate. It's been saved successfully. Now it has changed our values from the old national average figures to a Boston, Mass, specific to the model that we chose with glass and metal curtain wall and a steel frame. So we have $5,316,000 or $177 a square foot today cost to build this 3-story office building in the Boston, Massachusetts area. Many people are very fixated on that initial cost of construction. But in our world, we're looking more at the full life of a project, life cycle cost. People are more concerned today with looking at the entire value of a building. So as we get ready to move into the life cycle arena, let's just take a look at the full breakdown of the model that we chose, customized to the Boston area. And now it goes division by division. We're using the uniformat methodology of breaking things out, since this is all an assemblies cost. And it gives us the cost by division and subdivision as you build a building out of the ground. So this is some great information for our initial cost of construction. Here we can do some modifications if we so choose. For example, if our spread footings, which we priced at 3,000 PSI concrete, if we really meant to price it out at 4,000 PSI, we could make a change in this model. We're not going to do that now. We want to spend our time in moving towards looking at the life cycle cost. So what I'm doing now is at the top of your screen, you'll see that I'm clicking on life cycle cost, and that's taking us to a new screen here. We're first met by a welcome to the Means Online Life Cycle Cost Estimator. This is a great wizard or a walkthrough of what we have to offer here. We're not going to do that today, but now we're into the Life Cycle Cost Estimator. Let's look at what we can do at the top first. The top section of the screen is called Sustainment Model. The year built, right now it's showing it's built right now, 2016. Our building was really built several years ago. So we want to get back to the original build date. I'm going to just say it was built in 2010. However, we're going to note that we believe that we have done the proper maintenance, repair, and preventive maintenance over the initial 6 years of the life of the building. And so the start year for our analysis will be 2016, this year. The time period that we want to choose from, we have the capability of plugging in whatever time period we're looking at. Most often in facilities management and in capital management of organizations, you're looking at 3, 5, or 10-year plans. Let's just say that we're going to look at a 10-year plan here to look at life cycle cost for our building, which we already nailed the original cost of construction. But now we want to look at the next 10 years and see what applies here. So we filled in those attributes. Now we want to go to calculate. So we've done some recalculation. Now we want to look at what we have here, and we look at the assembly information on the screen. Just as we saw previously, it breaks it down by not only divisions, but components within the division. But we want to look at the types of costs that are being expressed here. We have replacement cost for the various elements. The frequency. For me, this is a great piece of information. Using national averages and industry standards, how often should you expect to make, for instance, minor repairs to a concrete floor once every 15 years, or replace that floor once every 75 years? That's great data, and that will help kick out our cost for either the minor repairs or the total replacement. We also have a category, a column that says year of last major replacement. So if we weren't just starting with that the project was built in 2010 and we're starting with 2016, if we really knew that we did minor repairs maybe in 2004, we could plug that in here, and then it would calculate forward based on the 15-year increments starting with 2014. Then we go into color-coded activities, maintenance and repair, the task itself, the cost for the task, whether there was any preventive maintenance. Notice that preventive maintenance probably won't show up early in our the way that we have things arranged here, because those are the things that take it's the building foundation and the building structure itself. But as you get down into the maintenance, more into the mechanical and electrical areas, that's when you'll start to see, like here for an elevator, you'll start to see preventive maintenance money and tasks start to come into play. Now let's take a look at the summary table. Much of the same information up the top comes in the sustainment model section, but we have some new information here. Aside from the year built and the start year, which are already populated, we have the labor inflation. 3.5 is not a bad starting point. We could change that to any number that we wanted to. Let's just make a change. So let's just use a 3% even labor inflation rate. The maintenance repair sustainment factor, if you saw a need to add a percentage because you have unique conditions in your organization, or you're dealing with a very difficult building or unique economic challenges, you may choose to ratchet this up a little bit. Again, that's from a factor of 1. We'll choose to leave that just as it is right now. We can also put in a replacement inflation factor, percentage of 5 as a starting point. Let's just make a change there. Let's just make it 4%. Again, based on recent economic information, or you could use past information and extrapolate it forward using means historical cost indices, for example. Not a bad starting point. So we have the capability of really fine-tuning and looking forward with inflation rates that we're building in. Replacement sustainment factor, again, unique, difficult, challenging things unique to your facility. You may choose to bump your number up a little bit. So now we've reset some parameters here. We're going to calculate again, and now we've changed things to all the parameters that we have asked for. I want to save my estimate here. I'm going to put in, once again, RS means. Now we've got this thing saved in 2 different venues here. We're saving. And now let me talk through the information that we have available here. We have the 10-year time frame. We have preventive maintenance cost per year. We have maintenance recost per year in the current year cost, 2016 cost, replacement cost and 2016 cost, and then sustainment cost based on the current year, which the sustainment cost is basically the preventive maintenance, the green, plus the blue, the maintenance repair, plus any white current year cost, adding up to the sustainment cost, divided by the replacement value would give you this percentage, the sustainment ratio. By looking down the years column, you'll be able to see where your majority of your money is falling and give you the ability to plan ahead with your capital projects or your operational budgets in the proper fashion. We do want to also look at preventive maintenance, maintenance repair replacement for the indexed year. Okay, basically this means is applying your labor inflation rate and your replacement inflation rate for the cost, looking ahead in the 10-year period here. So we have current dollars and we have index dollars, basically, is what we're looking for in these columns over here. Again, a powerful tool to help in the financial analysis and the proper allocation of resources. One last thing that we really want to give you a quick look at is how we correlate this information and allow you to put it in a presentable form. So we're going to show you a chart of your expenditures over the time frame that you selected, a 10-year period for a 3-story office building with glass and metal curtain wall in Boston, Massachusetts. And by colors, it's giving you the maintenance repair cost. It's giving you the preventive maintenance cost. Zooming in to show you some different pieces of information. But again, it's in terms of your presentation, just a good tool to allow you to present things. So what we've done here is take a look at the total cost of construction and maintaining and repairing a building for a 10-year period. So great cost data to start with, great cost data to work our way through maintaining a building, doing preventive maintenance, doing replacement costs. So we hope that we've provided a tutorial here on how to get us in a better position to sell our cost estimate to our bosses.
Thanks, Dave. Before closing out, we want to share a free 30-day trial of Lifecycle Costing. Just visit rsmeans.com/trial. Thank you all for attending, and we appreciate the questions submitted. As you exit today's webinar, you'll be asked to answer a few survey questions. For more information about this topic and other upcoming webinars, please contact me at n.benke@thegordiangroup.com. Thank you again and have a great day.